Administration of file systems and security in Linux. Even the most casual user interacts with the file systems of the computer. Anytime we run an application, like a word processor or a web browser, we're reading and possibly writing data on a disk. The security of this data and the system as a whole is one of the prime responsibilities of a system administrator. So that's the two main topics for this nugget. We're going to talk about how to create and manage file systems, and then we're going to talk about security of the file systems and the system as a whole. All right, so let's get started. Okay, so like I just said, first we're going to talk about mounting and managing file systems. And we can't really talk about file systems without also talking about disk partitions and devices. So we'll cover these as one big group. And then we'll talk about security in Linux. First we'll talk about best practices. These are techniques that you should employ to maintain good security in your system. And after that we'll talk about risks. Even if you employ the best practices, there are still security risks in your system, and you should understand what those are before you get started. Now let's talk about some commands that we can use to manage file systems, partitions, and devices. We use the makefs and fdisk commands to create file systems and partitions respectively. And then we use the fdisk and fscheck commands to examine partitions and file systems. We use these commands to mount and unmount file systems, partitions, and devices. Now, I was the 6th grade spelling champ, and I know this is not the way you spell unmount, but it is the way that you spell the Linux command for unmount. They just leave out the N for some reason. So the umount command is used to unmount file systems, partitions, and devices. We use these commands to get info on disk usage. The df command tells us how much space in a particular file system is being used, and the du command tells us how much space on a physical disk is being used. And these are just important directories that we're going to need for this discussion, the /mount directory and the /dev directory. Before we go any further, we should answer this question. What is a file system? If this term is confusing to you, that might be because we use the word file system to refer to two very different entities. One of those entities is the directory structure of the computer, and we've seen some of this already. Things like /etc holds config files and /home holds users' home directories, things like that. The directory structure is practically the same on every Linux system. There are some minor variations, but not many. The other meaning of file system is the low-level organization that's used on the disk to store the files and directories. If you want to think of it like this, here's an example. The disk holds a bunch of magnetic impulses, right, like positive or negative charges, and these can be interpreted as zeros and ones. Well, the various file systems, of which some are x2fs, this is probably the most common one that you'll see, x3, which is an extension of that, the riser file system. All these file systems, they can maintain the same directory structure, but what they do differently is they use different low-level data structures to interpret the bits on the disk, if you will. I'm going to use the term file system to refer to both of these, and I'll just make it clear from my discussion whether I'm talking about a directory structure or whether I'm talking about the low-level organization of the disk. To do these commands that mess with the file systems and the partitions, we have to be the root user, so I'm going to switch over to be the root user. And then the other thing that we should check is to make sure that the directory where these utilities are located, we have to make sure that that's in our path. So you can see the makefs utility is in my path. It found it in the /sbin directory. Okay, and you'll see the fdisk command and the fscheck commands. They're also in the /sbin directory. Now first note that this is not the user sbin directory that we've seen before for other system administration utilities. It's just plain old /sbin. Okay, and another thing before we get going here is you have to realize that these commands can do some real damage to your system. When we installed the system, we had the installation program create some partitions for us. If we go back and delete those partitions or try to repartition the partitions or reformat the disks, things like that, that's going to delete a bunch of data, if not all the data on the disk. Okay? So when we use these commands, we have to be really careful and know exactly what we're doing before we do them. So the first thing we're going to do is do the fdisk commands with the lowercase l option. And what this does is it lists all the disks on my system and all the partitions on those disks. And you can see from the result here that I only have one disk. Okay, this is all entry for one disk, and the disk is the dev SDA disk. Okay, what does SDA mean? Well, SDA means the SD stands for a SCSI disk. If that was an HD, it would be a IDE disk. And the A stands for the first disk. So SDA is the first SCSI disk, HDA would be the first IDE disk, SDB would be the second SCSI disk, and so on. Now, looking at this thing here, we can see down below, these three things, these are the three partitions on our SDA disk. It's SDA1, SDA2, and SDA3. The first partition here is the boot partition, and you can tell it's the boot partition because it has an asterisk in the boot column. In this partition, what resides there is the Linux kernel image and also some config files that are needed for startup. And you'll see the size of this partition is 48,000 blocks large. I think a block is a kilobyte, but we'll see for sure later when we do some other stuff. The second partition here, SDA2, is what I would call the main Linux partition. This is where all the user files are located, the log files, things like that. And you can see the size of this partition is huge compared to the boot partition. It's probably 75 to 100 times larger than the boot partition. Okay, now let's see, what else do we want to talk about here? The third partition here is the swap partition. Now this partition, the swap partition, gets used when your main memory fills up. So if you use up all your RAM, you have applications open, Windows open, and all your RAM is used, and then some application needs some more RAM, then what happens is the operating system takes something out of RAM that hasn't been used in a while and writes it to the swap partition. Okay, then that opens up some RAM so your application can use that RAM. If the stuff from the swap partition needs to be in RAM later, then it's brought back in from the swap partition and something else is put out to the swap partition. Okay, so this is like, it just extends your main memory. Now we could get away, in theory, with just one partition, not with three partitions. But here's why we have three partitions. We don't need a swap partition. We could have what's called a swap file instead of a swap partition. But swap files behave much more slowly than a swap partition would. So that's why we have the swap partition, for performance reasons. Now these two partitions, in theory, again, could be condensed into one partition. We could have the boot stuff in the same sector or in the same partition as the user stuff and the log files and everything. However, on Intel machines, the size of the boot partition is limited, okay? And that limit is actually pretty small. So what's going on here is that we separate out the boot partition because the boot partition on an Intel system must be small, and so all this stuff will fit into that small space, whereas all this stuff wouldn't fit in there, so we create a separate partition for all the user files and the log files and all that stuff. Another way that we can use the fdisk command is to type fdisk and follow it by the name of a disk. So here we're going to talk about the first SCSI disk. So now we're at the fdisk command line, and I can type various letters here to execute various commands. I'll hit M to see the menu of commands. So here you can see there's D for deleting a partition, and N for adding a new partition, P for printing the partition table. This would be kind of like what we saw with fdisk with the lowercase l option. Now, if I deleted a partition, I would definitely be wiping out some data on the disk. If I added a new partition, I would be cutting into the space that some other partition uses, and so again, I could potentially wipe out some data. That's why I said these commands are very sensitive, and you have to know exactly what you're doing when you execute these. Now, one time when I would add a new partition for sure is when I added a new disk to my system. So say I plugged in a new disk. The first thing I would do would be add a new partition on that disk. Okay? After I do that, then what I have to do is I have to format the disk or make a file system on the disk. So let's look at how to do that. I'm going to quit out of the fdisk menu here, and let's look at the man page for makefs. Now makefs, this is what's used to build a Linux file system. And equivalently, this is called formatting a disk when you make a file system on the disk. Now the options for makefs, the capital V option means that we're going to have verbose output, which means it's just going to tell us everything that's going on. The -T option we use to specify a particular file system type. Now if you don't use the -T option, the default is the ext2 file system. That's the most common Linux file system. But if you need some other one, you have to use the -T option to specify it. And then there's other various options, things like we can check for bad blocks, places where the disk is corrupted, things like that. So again, when you're going to add a new disk to the system, the first thing you do is create a partition on the disk, and then you make a file system on that partition so that the operating system can read and write to the partition. The last command of the trilogy of commands that can really mess up your file system if you're not careful is the fscheck command. And this command checks the file system for errors. Okay, what we do is we give it a particular device or partition that we want to check, and here I'm going to check the dev SDA2 partition. Now when I run this, a couple things happened. Let's talk about that. I ran the fscheck command, but internally the operating system ran the e2 fscheck command, and that's because I'm running an ext2 file system. That's the type of my file system. So the operating system detected that, and then it chose the e2 fscheck utility as the subset of the fscheck utility that I picked. Okay, then it told me that the dev SDA2 partition was mounted, and then it gave me this warning. Running this on a mounted file system may cause severe file system damage. And then it says, do you really want to continue? Well, the answer is like asking a kid if they really want to eat their broccoli. Definitely no. You don't want to continue here because it's a mounted file system, and moreover, it's mounted in writable mode. People can write to this partition. So while the check utility is going, if something's writing to the partition, either a user or the operating system itself, then the file system check utility gets messed up. It doesn't understand what's going on. Things have changed since it last checked, and then things will be lost inevitably. So you don't want to run this on a mounted file system, especially if it's mounted in writable mode. If it's mounted in read-only mode, you can get away with it, but this one definitely is not mounted in read-only mode. Now you don't have to worry too much about running this fscheck command because it's run automatically every time the system boots up. And you would get errors about that when the system boots up if there was any errors. So you don't really have to worry about running this manually, but you should know that it's there in case you do want to perform some checks. What you can do is you can unmount the partition or mount it as a read-only partition temporarily while you do a file system check on it. A few minutes ago we were talking about what we would do if we added a brand new hard disk to our system. The first step was that we created a partition on the disk. The next step was that we formatted it using the makefs command. And the final step is that we mount the disk using the mount command so that it's accessible to our system. Now I'm not going to mount a brand new hard disk because I don't have one, and instead I'll show you how to mount a CD-ROM. The first thing that you give to the mount command is the type of the device that you're going to mount. And for CD-ROMs, that type is ISO 9660. So you specify the type with the lowercase t, and then you spell out the type. Now I didn't remember this exactly. I had to look this up in a book, and you can do the same thing. Look it up in a book or on the web or on the man pages to see what type the device is that you're mounting. Then you give the name of the device, dev CD-ROM, and then you give the mount point, which is going to be /mount/CD-ROM. The mount point is the directory that you're going to go to see all the files that are on the physical CD-ROM. Okay, so when I go into the mount CD-ROM directory and do a listing, I'm going to see all the files that are on the physical CD-ROM. Let me talk about this once before we go on and hit enter here. You're probably wondering what this /dev/CD-ROM stuff is. Okay, well the CD-ROM is a file in the dev directory. And we've already seen /dev/sda1 and /dev/sda2. They were files in the dev directory as well. And what these files are is they're pathways to the physical device. Okay, this file here gives the operating system a pathway to get information off of that physical device. Okay, and one last thing, when I hit enter here, Red Hat's going to pop up a Nautilus window and graphically show me all the files in the mount CD-ROM directory. So don't get alarmed when a window pops up here. Okay, here comes the window. And you can see here it's for the mount CD-ROM directory, and this is the only file on the CD, and now it's appearing in this window. So I'm going to close this window and go back and look at that message that got printed out. So it says this block device dev CD-ROM is write protected, so it's mounting in read-only mode. That makes sense because I don't have a CD burner, I just have a CD player, so it makes sense that it's in read-only mode. So what I want to do now is I want to go over to the mount CD-ROM directory and do an ls, and there you can see the exact same file that we saw before in the Nautilus window in the graphical format. Now what I want to do is I want to unmount this file system, or unmount this device. So I'm going to say unmount, and then you can either specify the device that you want to unmount or the mount point that you want to unmount the device from. You can specify either one. So I'm just going to say unmount dev CD-ROM. Oh, and it says the device is busy. Why is that? Well, that's because I'm in the CD-ROM directory. Okay, so if I get out of that directory, if I go back to root's home directory now, and then do the unmount command, okay, now it did it successfully, and if I do an ls on the mount CD-ROM directory, you'll see that nothing's there. So this was temporarily linked, because I did the mount command, the mount CD-ROM directory was temporarily linked to the actual device. Then once I did the unmount command, then that directory was no longer linked to the device, so doing a listing in there was empty. Now, one thing I want to note is that in most Linux systems, when you put the CD into the CD player, the CD is automatically mounted. And this, I just set it up here just so that I could do it manually. I could mount and unmount it manually because I think that's a valuable skill that you should have. All right, so the last couple commands that I want to talk about in relationship to file systems, devices, and partitions are the df and the du commands. The df command displays information on file systems, how much space is being used, how much is available, and so on. So let's look at one of these. So this is the main Linux partition here, and it tells you how many blocks there are, how many blocks are being used, how many are available, and what the percentage of the ones being used is. And then finally it tells you where the device is mounted on the system, or where the partition's mounted. Okay, so before we were talking about blocks and we were wondering how big they were. Well, you can see here that they are 1 kilobyte large. And the way that you would use this is you would just monitor with df every once in a while and look at your partitions, see how much space is being used in this used percentage column. If this number was like 99% for dev SDA2, I would do one of two things. One, I would get on the phone and call a retailer and say, FedEx me a new disk because I'm running out of space. Or two, I would go around and try and investigate and see exactly what is hogging all the space up. If this number jumped from 45 to 99 in one day, I would be alerted and I would try and find out exactly what caused that. And probably it's something in error, right? It's some process out of control writing to some file. If it's slowly creeping up every week, it goes from 45 to 46 to 47 to 48, and eventually it's at 99, then that's probably like usage that is just good usage. And when it got to 90 is when I should have been ordering the new disk, not when it got to 99 and I was in a rush. Okay? Now, another way that you can use the df command is with the human readable form, the lowercase h option. Pretty much the same, except it just displays the sizes in something that makes more sense to me than 303,560,056,000 whatever blocks. It just says it's 3.4 gigabytes, which is much more comprehensible to me. 1.5 gigabytes is used and 1.8 gigabytes is available. Now you'll see 1.8 plus 1.5 adds up to 3.3, not 3.4. Don't get too worried about this. This is just like rounding errors. The available space is always rounded down so you don't overestimate how much space is left. But again, it's a good indicator, general trend of what's going on in your system. Like I said, if this is 45 and the next week is 46, you kind of see a trend on how your system is growing. Okay. Now, like I said, if this jumped from 45 to 99 in one day, then I would look and try and see exactly where that space came from. One way that's good to do that is using the du command. Now, the du command, again, if used by itself, displays information about every single subdirectory on the whole system below where you're starting it. So I'm in the /home directory tree here. So it's going to do under /home, it's going to display every single directory and subdirectory for everybody under /home. Now this is going to scroll up the screen, and again, I just want to look at something here just to kind of give you an idea. This tells you that the Alice's KDE directory is 16, Alice's XAuth directory is 4. Now what are these sizes? Again, they're 1 kilobyte blocks, so you could just display it in human readable form again with the -h option. Du is the same sort of option with the lowercase h. And then you see that it's 4 kilobytes for the XAuth directory and 16 kilobytes for Alice's KDE directory and so on. Now, so what it does here is it lists all the subdirectories for Alice, and then finally here it lists Alice's grand total. In some sense, that's the only thing that I want, right? If I just want to investigate and say, well, who's eating up the most space of all the users, and I can try and determine who has that big file that's being written to or something. So in some sense, this is all I want to see, and the du command gives me the ability to do that. So what I do here is I use the -- max depth option. Okay, and I say max depth equals 1. And I'll display it in human readable form. Now what this will do is it will go in and it will still count up all these subdirectories here. Okay, like Alice's KDE AutoStart and Alice's KDE and XAuth. But all it's going to display is the stuff that's 1 deep, the max depth 1. So 1 deep below the home directory is the only summaries that are going to be printed out. Okay, so let me do this. And you'll see that here we get Alice's is 52 kilobytes. Just like here it was Alice was 52 kilobytes. There it says Perry is 1.2 megabytes and so on. So this displays, it still goes in and counts all the subdirectories of Perry and Lisa and Alice, but it just displays the top level of those so I can get at least a rough idea of what's going on in the system. So using df and du, you can get a good idea on what's being used, how much is left, and where the use is coming from. Now that we've talked about how to create and mount and manage the various file systems, partitions, and devices on our computer, what I want to do now is talk about the Linux directory structure a little bit. Let's take a quick little tour. If we do a listing in the top level directory, you'll see a whole bunch of subdirectories here. Now, a lot of these subdirectories are on every single Linux computer that you'll come across. And furthermore, the meaning and the contents of these directories is practically identical from system to system. So let's look at the most important of these directories. The bin directory, in that directory are important binary executables. The ls command, for instance, the executable version of that command is in the bin directory. The copy command, the vi command, they're all in the bin directory. The boot directory is stuff that we need to boot the system. The Linux kernel image, some config files are in the boot directory. The dev directory we've seen holds one file for every device on the system. The etc directory is for system configuration files. /home under that is where the user's home directories are located. The lib directory is for shared program libraries. A lot of commands and utilities in the Linux system, they share some common code, and that common code is in the lib directory. The mount directory is where we mount removable media, things like CD-ROMs and floppies. The op directory is where we would install optional software. So if you had some prepackaged game or spreadsheet that you wanted to install, you would do that in the op directory. The proc directory is where we store information on processes on the system. We'll talk a lot more about that in some other nugget, so we'll just leave it at that for now. Under the root directory is the root user's home directory. System administration utilities are in the sbin directory. /temp is just for temporary storage. Any user can write to the temp directory. The var directory is for variable data, things like log files or users' mail directories, things that change over time. And finally, the user directory. This is a vast directory, and we'll talk about this carefully. When I had first learned about the user directory, I learned it stood for user-specific resources. And I think that meaning has kind of eroded over time. But let's go into the user directory, and I'll try to explain what I'm talking about. So we'll go into the user directory, and we'll do a listing in there. And one of the things I want you to see is that there are some subdirectories of the user directory, like user bin, and user etc, and user sbin, that have a corresponding partner one level higher with the exact same name. So the /sbin directory, we learned that directory has system administration utilities. Well, the user sbin directory also holds system administration utilities, but it holds those utilities that are specific to user administration. So the classic example would be that the user sbin directory holds things like the user add and the user delete commands, because they're user-specific system administration utilities. Okay, and remember the idea of the user directory here is for user-specific resources. So now the user bin directory, though, this is why I say the user-specific resources nature of this directory is kind of washed away or been massaged a little bit. The user bin directory doesn't really hold executables that are user-specific, really. It just holds stuff that's really not quite as critical to using the system as the /bin directory. We saw the /bin directory held like the ls command and the cd command and the more command and the move command and stuff that is critical to using the system. The user bin directory holds stuff like the clear command to clear the screen and some C compilers, stuff like that, that is not quite as critical to using the system. Now there are some subdirectories of the user directory like user include, user local that do not have corresponding directories one level higher. The user include directory, that's if you want to include some particular function in a C program, you would include that from the user include directory. The user local directory would be stuff that's local to this particular machine. If we had a networked system here, all these directories we could set up to be shared across all the computers in the network. Then the user local directory would be local to this particular machine. So if I installed something in user local, then that would not be visible to any other machine on the network. And maybe I want it that way because it's some experimental thing or it's something I'm developing and I don't want everyone to be able to use it yet. Now let's move on and talk about security in our Linux system. First we're going to talk about the security of accounts and passwords, and then we're going to talk about the security of file systems and programs. And finally we'll talk about what's called set UID permissions. These are really important to understand, so we'll talk about those carefully at the end. Now, in terms of accounts and passwords, the two things that you can do as a system administrator are remove dormant accounts and get users to pick good passwords. Okay? Dormant accounts are accounts that are no longer used, or perhaps they're accounts that have never been used. At a university I used to teach at, the students would sign up for a class and get an account, but then they'd drop the class before the first day and their account would just sit there the whole semester. Okay? This is a way in for people, the dormant accounts, because if somebody cracked into a dormant account and changed the password so they could repeatedly get onto the system, the person that owns the account would never even know because they don't ever log in, so they wouldn't even know that their password's been changed. And then the other thing you have to do as a system administrator is get users to pick good passwords. How do you do this, you might ask? One word: education. You have to explain to users what a good password is and why it's important to pick good passwords. So you might be wondering yourself, what is a good password? Well, here's a good example of a password. Great Scott. Okay, maybe I use the number 8 and the number 0 in there in capital and lowercase letters, and so I've mixed it up, and that's a pretty good word. What's a bad password? Something like baseball. Okay, this is a bad password because it's a word in the dictionary. At a university I used to go to school at, a professor every semester would go around and he wrote a program that would go through all the words in the dictionary and try every one of those words for everybody's account. It would take about one night. He'd started at like 10 o'clock at night, it would be done at 8 in the morning or something. And this would try to crack into everybody's account in the system with every word in the dictionary. Now, the surprising fact of this was that he got into over 1/3 of the accounts every semester practically. And that's because people were using bad passwords like baseball or a pet name like Brandy or Rover or something like that. And these are all words in the dictionary. So, no good. These are bad passwords. So like I said, get users to mix uppercase and lowercase letters, put some numbers in there, some punctuation marks, things like that. In terms of security of file systems and programs, the things that you can do as a system administrator, one is remove unnecessary programs. If there's some program on your system that's sitting there that's executable by everybody, but you don't know what it is, it's not part of the regular installation, nobody seems to take responsibility for it, things like that, then you should definitely get rid of that program. Because what it could be is it could be some sort of a backdoor into your system. Maybe somebody cracked in and got the root password once, and instead of changing the root password, which you would notice probably the next day, what they might have done was put this program in place that could give them root privileges if they ran it. Now, so you want to remove unnecessary programs. Don't just go around and remove every program that you don't know what it does. If it's part of the regular installation, it's probably okay. And then the other thing you want to keep track of are users' permissions for each other's files. The default permissions are set by what's called a umask value. This umask value is set in the etc profile file. And if you do a umask with a capital S option, if you just type this command, you'll see what your default permissions are. And for most Linux systems, there's something like this. Read, write, and execute for the user, read and execute for the group, and read and execute for others. In some Linux systems, it might be just read and execute for the group and no permissions for the others. Okay, so you can set that, like I said, in the etc profile file. And you can examine it with this command. And the important thing, like I said, is that you don't want to have this be too liberal. You certainly don't want like read and write execute for group and others, right? Because then they could just go in and delete files at will. So you certainly want read permissions or read and execute permissions and less. You never want more than this as the default set of permissions for a file. Now I want to talk about those set UID permissions. I want to talk about what they are and also how you can identify when they're being used. So the first thing I want to do is I want to look at the etc shadow file for this discussion. Remember, this is the file where people's encrypted passwords are stored. So let's look at Perry's password here. And forget the $1, all the passwords start that way. What I want to look at is the next few letters, 3FOT. I think that's actually a 0 too. 3FU0T. Okay, just remember those few characters. Then what I want to do is I want to look at the permissions on the etc shadow file. Okay? So here, when we look at these permissions, you can see that it's readable by root and has no permissions for anybody else on the system. Okay? Now I want to quit being the root user. I'm going to exit out, and now you can see I'm back being the Perry user. Now what I want to do is I want to change my password as the Perry user with the password command. So it says, what's your current Unix password? So I type that in, and now it says, what's your new password? Okay, so I'll type my new password in, and I'll retype my new password. And now it says, okay, everything's been updated successfully. Now I want to switch back and be the root user again. Okay, so now I'm the root user again, and what I want to do is I want to look at the etc shadow file again. Remember, the first few characters of Perry's encrypted password was 3FU0T. Okay, now I want to look at the etc shadow file again. Now if you look at Perry's password, the first few letters are ST8E7. It's different, right? It's different than it used to be, but Perry doesn't have any write privileges to this file. In fact, he doesn't even have any read privileges to this file, as we saw before. Nobody on the system has any read privileges to this file at all, but yet somehow Perry changed this file by running the password command. How did he do that? Well, the secret lies if we look at the permissions of the actual password utility, or the password command. The password command is located in the user bin directory. Okay, so let's look at this, and let's look at the permissions on this file. Okay, first you can see that it's executable by everybody on the system. Okay, all the group, all the others permissions are executed on this file. So everybody can run this file. But then let's look at root's permissions on this file. Root can read this file and also S this file. What does S mean? Well, S means that it has set UID permissions. So what happens is, when a normal user runs this program, and they're allowed to run the program because it has execute access, when they run the program, at some instant in the program when they need to write to this file to change the encrypted version of the password, they are setting their user ID to be the user ID of the file, which is root. So all of a sudden they have root access for that instant when they write the file. That's what the S stands for, that for some instant you get the root access to this file. Okay? Now, in old Unix systems, this was a real security flaw, because what people would do is they would run some command that had set UID permissions, and then what they would do is they would suspend operation right in the middle somehow. And then, since they suspended operation right in the middle, they would have root access to do whatever else they wanted on the system. Okay, so that was an old security flaw. Now it's been pretty much cleaned up, and anything that has set UID permission, if it's a user, like if it's a regular Unix utility, then it's okay, all right? But if you see some other utility in the system, some unnecessary program, like we were talking about those programs that you should remove from the system, if you see some unknown program and it has set UID permissions, then you should definitely get rid of it, because probably it's been set up as some sort of a backdoor into your system. Okay, so like I said, the set UID permission is pretty safe on all the built-in utilities, but if it's some other utility, then you should definitely get rid of that. Let's wrap up this nugget with a review of what we talked about. We talked all about the administration of file systems and security in Linux. First, we talked about mounting and managing file systems and partitions and devices on your system. And to do that, we learned the commands makefs to make a file system or format a disk. Then we talked about the fdisk command and the fscheck commands. And don't forget, all three of these commands can be really dangerous and wipe out data on your disk. So be sure you know exactly what you're doing before you use those. Then we talked about the mount and unmount commands, and then we talked about the df and du commands to examine how much space was used in your file systems and on your disks. Then we talk about the security in a Linux system. First, we mentioned some best practices, things like removing dormant accounts and getting users to pick good passwords, things like that. And then we moved on and talked about the risks involved in a Linux system, things like the set UID permissions and unknown programs floating around. And especially, you should be really leery of unknown programs with set UID permissions. And don't forget security measures like locking the server room door and things like that. Sometimes these common sense security measures are the best security measures you can take to keep your Linux system secure. Well, I hope you found this nugget informative, and thanks again for viewing.